Hello everyone, welcome back to my YouTube channel. Today we are diving into the exciting world of natural language processing with focusing on image captioning. The first step in machine learning project is import the necessary libraries. In our case, we are using popular libraries like TensorFlow, Keras and Matplotlib. Continuing setting a random seed is a critical step for ensuring reproducibility in machine learning experiments. Let's dive into the functions. The function set seed ensures that our experiments are reproducible by setting the same initial random state. Here we define the directory of our images, JPG, and the location of the caption. Now let's process the caption data. We read the content of the caption file, split and create a data frame for better organization. We read the content of the caption file, split and organize the data into a data frame for easy manipulation. The data frame df.txt has columns, file name, index, and caption for each image information. We print the number of unique files names and distribution of the number of caption for image. Now we are visualizing a subset of images along with their caption. We utilize Keras for image loading and Matplotlib for visualization. We utilize Keras for loading images and Matplotlib for visualization them along with their captions. The code selects a subset of images and pick is equal 5 and displays them in a 2-column grid. Caption are positioned below each image, providing a quick overview for the dataset. We have created a data frame to explore the vocabulary and word frequencies. Now let's continue with the process of cleaning process. We are removing punctuation, singles, characters, and numeric values. The remove numeric function removes numeric values and we print whether each word is alphanumeric. We define a function textClean which combines the previously defined cleaning process to process a given text. We then loop through the captions in the data frame. Now let's visualize the word frequencies in the clean dataset. We will plot top 40 and bottom 40 words to gain insights into the distribution. We define a function plot histogram to visualize the word frequencies using a bar plot. The function takes a data frame subset as input and plots the word against the frequencies. We calculate word frequencies for the clean dataset and plot top 40 and bottom 40 words for better understanding. Now we will enhance our captions by adding start and end tokens. These steps makes it easier to identify the beginning and end of the each caption, especially when dealing with the captions of varying length. We define a function add tokens to prepend start sequence and append end sequence to each caption in the dataset. These steps helps in identifying the start and end of each caption, facilitating further processing. Deleting the last layer of the model. Now let's modify our VGG model by removing the last layer. This is often done when we want to use the model for future extraction rather than for classification. We create a sequential model and add all the layers for the original VGG model except the last one. The modified model is created using the function API. We display the summary of the modified model to verify the changes. In this step, we remove the last layer of our VGG model, making it suitable for future extraction. This part is image loading and future extraction. Now we will load and pre-process images and extract features using the modified VGG model. Let's dive into the visualization. A selection images of that from clusters within our dataset. This cluster is based on embedding derived from our image captioning model. In this visual representation, we showcase selected images for distinct clusters. Each row corresponds to a specific color-coded cluster and each column represents an individual image within the cluster. This display offers a tangible glimpse into how our model groups and interprets visual patterns within the dataset. In this step, we create a data frame using focusing on images with only the initial caption. The result data frame includes file names, corresponding captions, and actual image features. Is tokenization and vocabulary building. Tokenization caption using a maximum vocabulary of 6,000 words. The resulting vocabulary size is printed and the caption are converted into sequence for further processing. Here the vocabulary size is 4812. The data split explanation. The data set is split into training, validation, test stages with a proportion of 80%, 10%, and 10% respectively. This ensures a balanced distribution for modeling, training, and evaluation. Data processing. The processing function structures input data from the model by creating sequence of captions, applying padding, and converting output text to categorical format. This ensures compatibility with LSTM model architecture. Model architecture summary. Here we define a neural network model with a combination of conventional and recurrent layers. Model training. This model is trained using a batch size of 64 per 6 approaches, optimizing with Adam optimizer and categorical cross entropy loss. TensorBoard is utilized for tracking training process and visualizing matter. Caption generation. The script generates captions for a set of text images using the trained model and visualize them along with the respective images. Visualization, captions, and blue scores. The code calculates blue scores for generated captions and visualize images along with their true and predicted captions. It's categorize predictions as strong or weak based on predefined blue score threshold.